Bonjour and welcome to this video. Today we'll be covering a new chapter, Chapter 2, Quadratics, in which we'll be covering Unit 2.1, Solving Quadratic Equations. This will be the chapter overview of the next coming videos in Chapter 2. Unit 2.1, Solving Quadratic Equations, which should be fairly easy. Unit 2.2, Completing the Square, should also be fairly easy. Unit 2.3, Quadratics as Functions, should be fairly easy, but maybe some questions may be new. 2.4, Quadratic Graphs, fairly simple. 2.5, the first new topic, which is finding the discriminant, and Unit 2.6, which is modeling with quadratics, which is also new. Today we'll be covering Unit 2.4, as I've already said, so let's start. First, here's a quadratic equation. In a way, there are three ways we can solve it. One is by factorization, another one is by quadratic formula, and the other one is completing the square, which, as I said before, is the next topic. So first, by factorization, we put it in the form of ax squared plus bx plus c equaling to 0. And in this case, we get x squared plus 2x minus 3 equaling to 0. We factorize as normal, and we get our two answers as minus 3 and 1. With the quadratic formula, which you should have done in GCSE, we also get 1 and minus 3. Next, what if the subject appears twice? In this case, x minus 2 squared equals 3. We could expand it, but that would just be very complicated. So we move the squared to the right, which is a square root, and we should get 2 plus minus root 3. If you can't see why there's a plus minus, think about the solutions. X squared equals 3. So positive root x, positive root 3 squared should give you 3, but minus root 3 squared should also give you 3. Therefore, x should be plus or minus root 3. Or you can get quadratics in disguise. In this case, when we have an expression with x, we say it's a quadratic in x. However, you may get quadratics like the one shown on the screen, which is cos x squared plus 5 cos x plus 4. We say that this expression is quadratic in cos x. Solve this question. So firstly, there are two ways you could do it. First, by substitution. Second, by factorization. By substitution, we change the values, the letters, and in this case, we let y equal to root x. So x minus 5 root x plus 4 changes to y squared minus 5y plus 4 as y squared equals to x, and y equals to root x, obviously. And then we factorize into two brackets. We get our two answers of 1 and 4. We sub root x back in, and then we should get x equals to 1 or x equals to 16. Or you can factorize it and do exactly as you did in the last slide, and you should also get x equals 1 and x equals 16. Have a go at these practice questions. Okay, so first question on the top left, you should have got x equals minus 4 and x equals minus 1. Expand the brackets and move everything to one side as it equals to 0. Factorize them into two brackets and you should get the answers. The top right question is the same as the question on the last slide. You should get minus 1 plus or minus a half root 5. The bottom left question, square both sides and you should get x plus 4 equals to x plus 4 squared. Move everything to one side, expand the bracket, and you should get x squared plus 7x plus 12 equaling to 0. And two brackets should be x plus 4, x plus 3, and you should get x minus 4 and x minus 3. X equals to minus 3, sorry. Bear in mind, when squaring both sides, always check the solutions at the end, as you may get some that do not work. As in this case, and as in some cases, you may get a negative number, which gives you a negative answer in a square root, meaning it would not work. And for the final question, you would put them in two brackets. You should get 2 root x minus 1 root x plus 1 equals to 0, where root x equals to a half or root x equals to minus 1. But however, you cannot square root a number to give you a negative number. Therefore, root x equals to minus 1 is not a solution. Therefore, the solution of x is a quarter. Have a look at this extension question. Okay, it looks all tricky. However, it is very simple. Find a common denominator, which in this case is x plus 2. Simplify the fractions, which in this case you get 2x plus 2 over x plus 2 equaling to 28 over 195. Cross multiply, which in this case you should get 195 2x plus 2 equaling to 28x plus 2. Simplify it to get this. Move everything to one side to get 0 equals to 28x minus 334 minus 390. You can simplify it by dividing by 2 and getting 14x squared minus 167x minus 195. And then using the quadratic formula, which I deem to be the easiest, make a equal to 14, b equal to minus 167, c equal to minus 195. Plug in the numbers and you should get 13 or minus 15 over 14. However, in the question it does say that x is positive, x is 13 only. Always read the question, otherwise you may end up making a mistake. Thank you for listening to this video. Hope you have a lovely day, and please subscribe and like to my channel. Thank you.